Friends, today we are going to discuss a very important topic that is called tank fabrication and in different parts. The purpose of these parts for this tank in detail and some code and standard. So before going to discuss the manufacturing of tank, we should know what is the type of load the pump is subject to uh, involve. Then these are the loads which are acting on the tank, that is called live load, nozzle load, seismic load, then gas pressure, hydrostatic head, then wind, vacuum load, dead weight, and snow. All are the loads that is acting on the tank, surface of the tank, and due to this load, the tank is subjected to hoop tension, then axial compression, then local stresses, and then vertical bending. Due to all these loads, these are the consequences of the load. So tank are subject to hoof stress, then axial compression, local stresses, and vertical bending, etc. So we are going to discuss what is the load. I have told you hydrostatic load. Hydrostatic load means the weight of the storage liquid is often classified as liquid load or hydrostatic load. Whatever liquid is there inside the tank, that is called the hydrostatic. That will give some load, gives some load on the tank cell and bottom. This is called the weight of this liquid store inside the tank is called the, due to this, that is called the hydraulic load. Dead weight means for manufacturing of the tank design, the dead weight includes the permanent stationary self weight of the tanks, that is called the dead weight. Tank weights means its cell weights, physical components like cell, roof, bottom plates, and internal structure is there, rung, etc. Plus associated piping is also connected, inlet pipe, outlet pipe, drain pipes. There's so many pipes are there. So valves, safety valves, isolation valves, etc. And insulation, some valve tanks are subject to keep some insulation to maintain its temperature. That also, all these components includes in the dead weight, considered the dead weight. Live weight means suppose some personnel are working on the top platform, roof, they are live. This will be considered as a live load. Live load. So these are the three main loads. Plus other loads are, I have mentioned you, the nozzle loads. When the pipe is connected to the vessel or tank, it will giving some, due to some expansion and contraction of the pipeline. It gives some force on the tank. Then seismic means, tremendous load will come, that will discuss in detail. The ground will shake. That for that, this will give force on the tank body. The hydrostatic I have already discussed. Gas pressure inside the gas, some liquids are there. If it is temperature is changing, then some gas will form, that will try to escape through the roof. That will give some lifting force. So that is also one type of force. Wind is of course there, because any direction wind can come, that will act on the tank body. Then vacuum, suppose you are drawing material and you are not breaking the vacuum, then tremendous force will act on the tank. That will also compressive strength will be, it will axial compression, cell will subject to compression. Day to day, I've already discussed snow in the winter season, or particularly the particular winter region, the places there are a lot of snow, so will fall, and that will also create some load on the tank. Now, due to these loads and stresses, what is the shape of the tanks? The tank can sink, you say, due to the own weight of the liquid and the body weight, it can sink. If the foundation is not proper, then it can go inside the foundation, that is called tank settlement. This is the piping. That piping can deform. It is settled, then piping will deform, and not only that, pipe itself, it will give some force on the tank if it is not properly connected. This will give some tension, give some axial and radial force on the tank. That's why it is this is also play an important role. Then thermal growth, due to a temperature, there will be the diameter will increase. That will increase. That is called the thermal growth. This one is called the thermal growth. Due to weights, the bulging will take place. Due to weights, at the bottom there will be more weight, so it will bulge on the bottom side. That is called a tank bulging due to liquid head. So these are the changes of the tank will take place due to this force and the load. Then oil, going to tell you something about the oil storage tank base requirement, because it is important that the base on which the tank stand is fit for the purpose, because if base is not strong, when foundation is not strong, then a lot of problem can create. So when the suppose tank is full, then suppose it is having the oil, so we can consider the for 1,000 liters the weight of the liquid will be 1 ton. 1 ton plus weight of the tank itself. Tank is manufactured with some material, iron and etc., iron plates and others, and some structure is also there, that is also having some weight. So all these weights will be there when the tank is placed on the foundation. So that foundation should be, if there is any oil erosion is there, soil erosion is there, then there will be a lot of problems. Erosion should not be there. Then uniform structural support structure, the support of the tank will be uniform, one side bigger and one side less. That should not be there. And even if it is there, and it should be properly leveled also. If it is not there, then the fracture of the tank fracture and piping fracture can take place. Then it must be leveled, because the tank should be leveled, vertically leveled. Vertically it should be leveled, and non material, foundation material should be non-combustible material. If some fire take place in the foundation itself, then there will be a lot of heat will generate, and that will collapse the tank. And so it should be made of solid concrete, and paving stones and stonework should be perfect. Should be perfect. And for the foundation should be at least 300 millimeter, means around 200 to 12 inch, 12 inch away from the sail site. So projected from the sail site. If tank is there, then it should be projected by both sides, all over 300 millimeter. And nearby equipment should be at least, nearby tank or nearby equipment should be at least 1.48 meter from the tank body. This is the requirement of the for manufacturing of the tank. Then I have told you the foundation. First of all, foundation, there are different type of soils we have mentioned here. We don't know, for that you have to, when you install a tank, you have to do the soil analysis, and then as per the you see these are different type of soils are located in different regions. So if it is a gravel, sand and gravels, compact soil, then its soil bearing capacity, load bearing capacity of the soil should be how much? Now this is ton per meter square or kilonewton per, this is one unit is kilonewton per meter square. 440 kilonewton per meter square divided by 10, that will get the ton per millimeter square. Like that, different classifications are there. Different types of soft clay, if you very soft, just like a clay, if you put a heavy metal, it will go, certainly it will sink. So now you show you the calculation. Suppose fuel oil. I have already told you that for 100 liter, 1,000 liter means 1 millimeter cube, it will be 1 metric ton, 1 ton. So suppose that tank, for calculation purpose, tank is 10 millimeter dia, 10 millimeter, 10 meter dia, 10 meter height, and its plate thickness is, suppose uniformly, though it is not there, not possible, 10 millimeter thickness. So volume of the liquid will be how much? Now pi d square into h, pi d square into 10 meter, d square by 4, by d square by 4 into h, that will be, if you calculate it, that will be 385 meter cube. And 1 meter cube weight is 1 ton. So weight of the oil will be how much? Now 785 metric ton. Then volume of steel, how much volume of steel you have used for manufacturing of the tank, how you calculate it? Now that is be equal to now pi L, pi D is equal to pi D will be your pi D will be your circumference into height is 10 meter, the diameter pi d, this which will be your circumferential area, circumferential area, cell area. Then this will be top and bottom. The pi d square by 4, d is equal to 10, d square is 100 divided by 4 into both sides, top and bottom, 2 into 2. And then all have to multiply. Right? This is also pi d square by 4, this is meter square, this is also meter square into thickness. Thickness is 20 millimeter and 0.002 meter. That means if you multiply this, if you do the calculation, then its weight will be, steel weight will be 9.442. Volume will be 9.42 meter cube, and then weight of the tank will be how much? Metal weight will be 9.42, 7.8. 7 is the key, the density of iron. So iron is at the metric ton, 7.8 metric ton per meter cube. So this is the meter cube, but that is the surface area, is that is the surface volume, metal volume into the thickness into density, that will be 52 metric ton. So what is the total weight? Now total weight will be, that is your 785 plus 52, that will be 837 metric ton. This 837 metric ton, now if you placed on a concrete or concrete foundation, that will work downwards due to gravity. So you have to divide the total area, this ton, this much ton divided by the total area, that is tank area is how much? Bottom side tank area, now pi 4 square, pi d square by 4, that is the d is equal to 10 by 10 diameter, pi d square by 4 is equal to 78.5 divided by 78. So this ton total weight divided by 78.5, that will give you the pressure, that will the weight of the tank plus weight of the liquid, that will give pressure on the soil. How much pressure will be there? Now 10.6 is metric ton per meter square. Meter square. Now meter square. Now we know the soil load bearing capacity is how much? Now 44 ton per meter square. So here it is, how much we have got? Now how much we have divided by 10.66, and now its capacity is for this, if you are make the foundation with sand, gravel, etc., then it will be 44 ton per meter square. So it will certainly be more than the 10.66, certainly be more than the 10.66, but actually it should be how much? Now 70% of the load bearing capacity of the soil. So 70% of the load bearing capacity means how much? Now it should be less than the 70% of the load bearing capacity of the soil. So load bearing capacity is 44 into 0.7, that is 30.8, and that is also greater than the load created by the tank on the soil due to its own weight plus liquid weight, that is only 10.66, and here it is soil load bearing 70% of load bearing capacity of the soil is 30.8. That means it is safe, very safe. So there will be no sinking. Now external force, suppose or external force due to wind, some external force will come, due to vacuum some external force will come, some internal compression will be there, and all this force, the wind force or vacuum, that will create the compressive stress will increase. So due to wind and due to vacuum, the compressive it will act on the compressive strength of the cell material. Then your dead weight and life weight. I already explained. For due to this, what will happen? Now vertical load, hoof stress, there is hoof stress and vertical load will come. Due to this vertical load, the hoof stress, the stress will develop, but this stress, due to this stress, it is called hoof stress. It is called tensile hoof stress. This will create hoof stress due to dead weight and live load. Due to dead weight and live load, the tank is subject to hoof stress or tensile stress. Then due to wind, Due to wind, I have already compressive, I have told you, but this is if it is uniformly acting. But if suppose wind is there on one side it is acting, then it will the side where it is directly wind force is coming, wind velocity is coming and strike, that one is called windward, and other side it will call leeward. So leeward will be subject to compression, windward is subject to tension. Windward is subject to tension. And this force, how we will calculate this force? Now pressure due to velocity into the pressure into the hydraulic area, that is L into D, L into D, the L into D. So this is for this. So this is called the due to wind. In one side it will be tension and other side it will be compression. Wind is flowing in one direction only. So the projected area will be D, that diameter, into H. This force due to wind, this pressure, if you know the velocity, you can calculate the pressure, and pressure into area, that will be the force, that will force acting on this side, and this side will on windward side it will be tension, and other side it will be leeward side, it will be tank will be subject to compression. And now you see the bending moment due to this force. What is the bending moment take place? You see, due to the wind, it will move upward. The tank will try to move upward. Then internal pressure, tank will try to move upward. Due to wind force, Fs, this that is called wind upward. That force we are calling Fr. Due to wind force, we are calling it Fs. This will also act on the hydraulic side, hydraulic projected area, the D into H, that is on the horizontal side, and dead weight and liquid weight, etc. That is called dWl, ds, liquid weight, the dead weight, it will move to downward. Suppose you want to calculate how much moment it will generate here. Due to all this force, we can calculate. I can show you there, next page. That is, you can see that is the wind force, and internal pressure movement will be like this. For wind, its movement will be from the middle at the h/2 distance. Here it is d/2, and dead weight, etc. Dead weight plus the liquid weight, it is moved downward. So if you're going to calculate the moment of this point, then what will be there? Now that is Fs into h/2, h is the height, total height, h/2, Fs into h/2. This will act on this direction. So this direction plus Fr will also move on upward. So Fr into d/2, here h/2, here d/2. This will also try to move in this direction, clockwise direction. Here it is also in clockwise direction, here it is also at per this point it is clockwise direction. So Fr plus d/2 minus, here you see it is dead weight plus liquid weight, dl plus wa, liquid weight dl plus wl, it is moving the this anti-clockwise direction, and that also d/2. So that is also into d/2. That is called the total momentum on this point. So due to this momentum, what will happen? This side bolt will try to move up, this side foundation bolt will try to move up. So that is, the foundation bolt will subject to force, upward force, up into this distance, up force into distance. This momentum due to this is equivalent to the force of the foundation force plus this d is the distance. So this will equal each other, where F is equal to shear force, or S is equal to your tensile force. So tensile force, A is equal to N is equal number of bolts. If you suppose the all periphery equal to equal numbers, so N is the number of bolts, and pi r square is your area of the bolt, pi r square, pi r square, the area, and then area, that will be the force of the bolt. Then the momentum will be distance into r, F into d, because from here it is d. Here foundation bolt is there, but actually all circumferential foundation bolt will be there. The bolt in the extreme end, it is subject to force into d. Here it is slightly less than d, or further less than d. So it will be divided into the number of distance will be varying. So I have written it here. Here the distance will be changing as per the location of each foundation bolt. This extreme end foundation 2-3 bolts will be subject to diameter d. Other end are from here and here here, it is not subject to the diameter will be less, and then you have to calculate the then you will get the total force. Total D you know, and location you know, then you, and bolt are all same size, so you will come to know the force of the bolt subject to install, and then you can calculate the if bolt is shear, then or bolt is tensile force is there, or shear is there, then accordingly shear stress and tensile stress you have to pi shear stress, it will be your area will be pi r square into shear stress, and tensile stress again it is same pi r square into tensile stress. So depending upon the how what type of stresses will be there, you have to you have to equal this, and then you can calculate the diameter of the bolt, okay? Diameter of the bolt. Now, due to earthquake, due to earthquake, the soil is moving, not tank is not moving. Due to movement of the soil, you see the to and fro, when it moving this side, liquid will move to that side, it will move upward is free, so tank shape will be like this. When it is moving, soil is moving on this side, though it will move on this side. So due to this earthquake, the tank is subject to, one side will be subject to, both side will be subject to tension and compression. One side when moving this side will be tension, this side will be compression. When the soil will move this side, this will be on compression, this will be on tension. Not only that, the fluid also move upwards when you moving this, and this side moving downward. Due to that, the shear stress will, due to that, the momentum is also going to change. Earlier we have explained, this picture we have explained that when the liquid are in the same level, but when the liquid are of the liquid are not in the same level, then this side liquid will move up, this side liquid will move down, so your momentum will also going to change, and accordingly you have to rigorously you have to calculate the strength of the foundation bolt. Now, due to earthquake, what will happen? I have told you, if you are suppose floating type roof, then this side, this much space, free board should be available. Otherwise, liquid will fall up, fall down, fall up from the overturning will be there, and liquid will from this side. Here it will come down to this side. This is the floating roof. This is the floating roof. So there is two type of forces are acting. Uplift force due to seismic is called convective and impulsive, and another one is impulsive. This one is called impulsive, this one is called the convective. Due to convective, it will move up, liquid will move up one side. This it depends how the your floating roof will move up. It is floating, but the contact between the surface and the rubber ceiling, that will give some force, that is called convective force. And impulsive force is also there, because this side weight will be more, this side liquid weight will be less, and this can create the shear, because the earth is moving, so this can create the shear of the bolt. And not only that, due to the changing of the elevation of the liquid, it can overturn also, because this side weight is more now, so it can overturn also. This can also overturn. So your base and as well as the designing of the foundation bolt, you have to take care not only the other weight, other load, but seismic load calculation is very important. Seismic load calculation is very important. Now, the main parts of the storage tank. The tank is consisting of tank shell. This one is called the tank shell. You see these are made of pieces. This is called the tank shell. This is the bottom plate. This one is called the inside the bottom plate. That is also made of pieces. It's called a bottom plate. Annular plate. I will show you the design of annular plate. You can see the third number is annular plate. You see this one is the annular plate. This is called the annular plate. The size of the annular plate is much more than the bottom plate, because here the vertical shell will be welded here on the annular annular plate. That's why the thickness of the annular plate will be much more than the bottom plate. Bottom plate. Suppose the shell thickness at bottom is 28, it will be gradually down. Of course, 28, then at least should be annular plate thickness should be that is would be 16 millimeter. And how much distance will be there from the center of the vertical shell? It will be 1.108.7, at least 1 meter, around 1 meter, 108 or 1.1 meter distance. Distance, then overlapping will be there. So this one is called the annular plate. So annular plate thickness will be much more than the bottom plate, and it should be less than the cell bottom plate. Cell bottom plate cell bottom plate. If cell bottom plate is 0.28 millimeter, then your annular plate thickness will be 16 millimeter. And all these data are available in 650 API 650. And this is annular plate. Then this once you calculate the thickness diameter of the foundation bolt, then the anchor bolt, foundation bolt, anchor is called anchor bolt. Then you have to know what is the anchor what is called the anchor chair. This is the shape of this. You see the plate is just like a chair. It's just like a chair. So why it is making the making it chair? Because the contact, you see, the along with the shell is more here. From here bottom, that is the bottom plate, annular plate, then this side with the tank, this side with the tank, this side with the tank, this side with the bottom plate. So the foundation bolt load will be distributed to this much area, this much area of the cell, this much area of the cell. Like this, there are so many foundation bolt, so much foundation bolt. So this is very important. And then this is the hole, this hole, and foundation bolt will pass through this called anchor chair. There is a hole is there due to, and this hole is oblique cut, or oblique cut means diameter radially will be more, because the cell will expand. When it will expand, if your if it is not, clearance is not there, then this foundation will be subject to tension. That's why it should be freely move. So that's why it should be move freely. And above the chair also some anchor, some reinforcement plate is also there. And not only that, the nut to be proper, to be tightened along with the washer, along with the washer. And for the anchor bolt, and this is equally spaced. This space should be equally spaced to all over the tank, all over the tank. And bolt material should be as per ASM F1554 or A307 or A325. There will get the detail of the foundation bolt length, as well as the shape, hexagonal nut, washer, etc. Everything will be available if you go through the ASTM F11415154, or this anchor bolt detail will be available. But this is but to increase the this area force, we are make it like this chair. It is called, like, looks like a chair, so that area of contact and force acting on, or if you are not using this, only this bolt, then it can shear off from the plate, bottom plate, it can shear off. But as it is a very big, it will be, load will be distributed to the cell also, the bottom plate also, so so it will not shear. Now in the cell bottom also, cell center or tank center, there is a then we are going back to our that is called annular plate. Backing plate is between, when you are welding the two plates, this is one plate, this is another plate. Then to, if it is do welding, start welding, then what will happen? This is due to moisture or sand inside, it will not, welding will not be proper. So we have to make a backing strip, so that the, when you are doing welding, the contact will be not with the soil, it will, all contact will be with the metal. This is called the backing strip. This one is called the backing strip. Anchor bolt, anchor chair and anchor bolt we have already explained. Draw up sump I am going to discuss now. Draw of sump is means this is the draw of sump where in the suppose the tank is having some oil, then the purpose of the this draw of sump is to take the heavier material, accumulate the heavier impurities that settle at the bottom, and prevent him at the bottom. That's why it avoid preventing the contamination of the main fluid, and this is the that's why it is called the draw of sump. And when you are draining, taking do annual inspection, then all the oils, then this from here you have to take out the heavier material. This is called heavier material. And this is one is the your rubber. You see the flexible rubber, then sand, and then this found then your base plate will be there. Base plate will be there. If it is any any water accumulation is there, then from here we are draining provision is also there. From here water will be drained outside. Drain outside. There is some slope is also there, so that any water is there, it will automatically go outside. So this is called draw of sump. So this is the draw of sump. Draw of sump we have already explained. Clean out clutch, that is when you the draw of sump outside, then to remove the, it can go to the trench. There is some strainer will be there, that is one is called the clean out catch. Nozzles are there. You see these are all the nozzles. These are all the nozzles provided on the tank to for these are all the manholes. This is also a nozzles, inlet holes, inlet outlet pipelines. That is called the nozzles. Then cell manhole, cell manway. Here from here also you can go inside. At the top also there is one manway that also must be provided on the for each and every tank. Manway. There is a cell manway. This is the roof manway. Fire safety, for if it is having a explosive material, then fire safety provision should be there. Above both all these sides of the tank, there will be fire safety lines will be there. If any catastrophe take place, there will be nozzles on the fire line. This will spray the water, and it will or foams, and this will extinguish the fire. Then primary and secondary wind girder. This is called primary wind girder. This one is called secondary wind girder. The purpose will explain later on. It will save the tank from your wind force. Otherwise it will sink. Wind force. So this will give the stability of the tank. That is called primary and secondary wind girder. Carp is also the same purpose, but carp will be slightly smaller than the wind girder. But purpose more or less same. This will give the increase the stability of the tank. Otherwise tank can collapse. Then roof plates. This one is called the roof plate. This one is called the roof plates. Then crown plate. This one is called the crown plate. These two are called the crown plates. This plate and this plate is called the crown plates. Crown plates. Vent nozzle. There must be some vent nozzle is also there. From here, when that you are draining we are taking out the material or fluids, then there vacuum will create. So if a vent is there, then this from the vent air will go inside, and both side it will create the same pressure. Otherwise, if you are not opening the vent, then collapse, because due to taking out the material, there will be vacuum, and due to this vacuum, the tank can collapse. So and overflow pipes. If it is overflowed, then there will be overflow pipes will be there. From here it will going outside. Overflow pipes. Roof structure. These are roof structure to go out inside, so that you can fall down. Roof structure. Internal pipe supports. If there is pipes are there, we have to give the internal pipe supports also. Internal manway. Or rungs to get down. There will be some rung, like this ladder. Made of steel, C-type channels will be welded on the tank, so that you can get down. So that is called rungs. Then external cage. You see this is the external cage. Roof handles. This is the going inside monkey cage to go roof handles. These are called materials, or all the materials required for manufacturing the tank. As I explained, chair also, foundation bolt, and this chair we have already explained. That draw of some I have already explained. This is called the wind girder. You see, this one is called the wind girder. If you are not providing this girder, then due to wind force, the inside bending will be there, because the shell material are not so strength, so it can go inside due to wind force. So if you are reinforce it externally with the C channels or L angles, then the shape will be remain intact. And this was called the primary. This top one is called the primary wind girder, and bottom one intermittent. This one is called the intermittent wind girder. This is keep the shell intact, strong against the external wind pressure. Reinforcement. These are then give reinforcement to the tank. Then carp angle. Carp angle is, you see, this is the carp angle. This is sometimes mounted with the shell. This is also, the purpose is same, but it is must for every tank. But wind girder is required when there is a for making any about in the top you want to make any passage for the vehicle, for the movement, personal movement, then your wind girder size will be much more than the top carb. Top carb is normally made of the angles, that the purpose is same, to give the to reinforce the tank, so that due to wind force the tank should not collapse, so this is mounted with the, sometimes it mounted with the roof, sometimes it mounted with the sail, sometimes mounted with the sail. So the shapes are given here. Now the difference between the carb angle and wind girder. Carb uppermost rims, and it is to and welded with the, directly welded with the shell tank. Here it is typically near the top, not on the at the top portion, and intermediate portion also the wind girder is provided. Then it is minimum structural stiffness. Provide minimum structural stiffness, but it is called, here it is very big structural stiffness, because size is more. That's why it is give a very big structural stiffness than the than your carp angle. And then on almost all tank it is required. Your A is required. This carp angle is required for all tank, but here it is wind girder is required on the top or floating roof, particularly in the floating roof type of tank it is must, and other tank it is depending on your requirement. It is only for it is made of simple L shape structural angle, but here it is made of a C channel bigger than the L shape, C channels etc. box, and much more size than the carp angle. This is the center crown plate. This is the center crown plate, and this is the two center crown plate. The top crown plate. This is the bottom crown plate. You see this. This is the top crown plate, and this is the bottom crown plate. And the bottom we are providing with the. It is welded with the beams. You see there is also beam. This is also another beams, and it is placed on rafter. Placed on a rafter. So this one, this particular two is called the crown plate. This two on the crown plate, and this crown plate is placed on the rafter. This one is called the rafter. You see the bottom hole here, the beam will place inside, and this is called inner this is called the inner top crown plate, and it is called the bottom top crown plate will be there. So bottom top crown plate and top crown plate and others plate will be welded on the rafter. Now the manufacturing foundation, when your foundation is ready, then what we are doing, we are putting this, you see, this is called the liner. It is called the liner. This one called the black one is called the liner. It is PVC sheets, simple HDPE sheets. They were provided on the gravel cess, and then above it, above the liner, we are providing the bituminous sand, so that compression uniform loading will be there when I place the tank. And then bottom plate, you see, that is the bottom plate. This one is the bottom plate. So first foundation, then foundation, above the foundation there will be a liner, so that if any water is there, this will not go up. Then your will be sand, and above this sand the bottom plate will be there. This is the you have to take care so that the moisture will not come in contact with the bottom plate. Then manufacturing of tank can be manufactured in three ways: the traditional method, jacking method, on integral lifting method. Normally 5 meter and above, we call it big tank, storage tank, whose diameter is storage tank. It will be whose diameter is more than 5 meter. Yeah, sometimes its diameter can be 40 to 50 meters also, and more than that also. Similarly, its height will be field inspection for fabrication and installation. This kind of big storage tank is not possible from outside to bring it here. So at site only you have to not possible, unachievable to transport. So we have to assemble the tank in the field itself. By first you have to manufacture the foundation, then you have to place the bottom plate, and all the plates will be erected at site only. So this erection can be done in three ways, that is called the traditional method, jacking method, and integral lifting and other site fabrication method. And before, when you are doing the fabrication, you see this is the cell, this one is the vertical cell. You see the inward, this one is called the curve, or your girder. Inside it should be perfectly matched. You see, not it is the bottom cell side will be size, thickness will be more, because the force will be at the bottom will be more. So to save the material, we are gradually reducing the cell thickness. But if you are but you have to match with the inside, otherwise a lot of turbulence etc will be there. So better you and liquid movement will not be perfect when you are using the floating type roof. If it is up and down is there, then floating roof cannot be moved smoothly. So that's why inside there it should be matched. All the cell inside should be matched. Outside projection will be there. You see, outside projection is there, and bottom side cell thickness will be more, because bottom pressure will be more. Then gradually at the top pressure will be less. So you can reduce the thickness of the cell plate. And you have to, this the type of welding is not correct. You have to match with the bottom side, inner side, so that there should not be any up and down, any projection. Now this is the traditional method, where we are doing bottom plate, and then we are one by one plate. So form plates we are bringing at side and hold it with the crane, and then they do welding. For when you are moving upward, we have to make the scaffolding, and to make the uniform gap with the help of the crane is very difficult. A lot of accident will take place due to this type of this is the traditional. Of course, this is a traditional method, but this is not safe. This is not safe for big tank. Small tank it is okay, but if your tank height is more and diameter is more, then with the help of this crane, if you are holding the plate, it will be very difficult to match the gap. And and there are a lot of every time you have to change the scaffolding, and scaffolding also you have to make very strong, otherwise there are a lot of accident will take place. Though this is a traditional method, but still we are not following it. We are following the this method. This method is called the jacking method. You see, for the jacking method, what we are doing, this is the top portion. This we are manufacturing first, and then we are jacking it upward and do one by one plate inside from the bottom side. If you see that sequence of operation, you see this is the bottom plate operation is there. Bottom plate installation is over. Then what we are doing? We are doing the top portion, top cell. Then put the rafter above the top cell. Then roof above the rafter. Again the roof in the roof. Then top cell and the roof is over. Then with the help of the crane, with the help of the jacking device, we are lifting the top cell gradually and fill it with fill the bottom portion. That is, this is safe because you have to do always welding at the bottom side, not at the top side. And lot of jackings are used so that and precise gap clearances can be maintained if you are using this method, jacking method. Jacking method is now following everywhere because it is more safe, more quality of job is possible, there is no accident, and job can be done very fast. Job can be done very fast. You see, this is the jacks we have provided on the top cell. You are gradually lifting the top cell, and the bottom cell we are welding here. Bottom cell you are putting here, and gap you are maintaining with the help of these jacks. With the help of this jack, you see, this is the jack. With the help of this jack, you can maintain the clearances of the and do the welding. You see, lot of jacks are there. You will see lot of jacks are there, and there you can put the total center position of the pump house. Center, you can say inside. It is remote control, and you can keep it outside also. And with the hose, you are lifting these jacks, and precise control is possible. Such a big tank only possible with the help of the jacking process. With the help of the jacking process. Then this is the prefabricated tank. Small tank can be prefabricated outside and then can be brought it back. Otherwise, you have to do it at site. When the tank size is more, then either do by traditional method or jacking method, or if it is tank size is more, then you can prefabricate it outside and bring it here with these saddles. You can place it in position. Place it in position. This is called the girder, top wind girder. You see, this one is curve. Top curve, it is made of only angles. This is made of angles. This is made of also angles. This is also, it is made at the top of the cell. It is top of the cell. Here it is slightly down of the cell radially. Here it is axially. Here slightly more than the top. This one is all called the this is called your this one is called your it is called the it is called the carp, CURB. This one is called the carp, CURB, carp. This is the carp. This one is the called carp. All are carp here. You see here the carp design are given. Carp and rafter design has been given. You see, this is the carp. It is mounted on the top of the sail. It is radially, slightly bottom of the sail. It is much more slightly less than that. And now this one is the rafter, wind girder. You see, it is made of channel. Its size is bigger. It is made of channel. Its size is bigger. Here you can make the platform also. You can walkway for your personnel. How to select this? How to select this carp? Now you formula is there. Z. Z is the required minimum sectional. If you put the diameter of the cell, h is the height. Then d square by h2. Here h2 is the height of the tank. And d is the nominal diameter of the tank divided by 17. You will get the required minimum section module. From the section module, if you there are a lot of sections module are there, and there you can select whether it will be C channel or it will be angle. If you get this value, you can you have to compare this value with the available chart of API 650. Therefore, this particular section module, they will give you the shape of your channels, shape of your section. It can be C angle, it can be channels also. Now, if your channels are not there, you are not that good do the steepener. You see, there is no carb or there is no wind girder. Then, due to wind force, it can tank shape will be like this. Go inside. If you use the girder or carb, then your this will be very less. This will slightly will be there, but it will be very less. Now, the purpose of reinforcement plate. Suppose you are making so many nozzles in the tank, tank due to its own weight, there will be tensile force will be there, compressive force will be there. You see, here it is uniformly distributed. But when there is a nozzles, then this total weight of the tank or the cell will be distributed. Here it will be more there it will be less. You see here it will be more, because you have to take the load of the cell. So it will be, if it is no nodules is there, it will be uniformly distributed. But if it is any hole is there, then it will be concentrated on this side to do the periphery of the hole, to the periphery of the hole, and again it will be distributed the outside of the other side of the cell. So if you see the next drawing, you see that it will be more on the nodule area, and other it will be distributed uniformly. At the outside it will be sigma, outside it will be sigma, but here in the no, there nodules are there, it will be 3 sigma, 3 sigma. This is the total load of the cell. It will distribute it. Here it will be sigma. You see, every year it is sigma. After this, it will be sigma. But particularly in the whole portion where the nodule is there, it will be and at the periphery of the nodules, it will be more. Shell will be that the stresses will be more, because there is no way you can carry. So stresses will be more. So you have to, as the stresses is more, there is a chance that it can shear from here. So we have to, and this is the, you see the distribution of the stress up to this, it is called the one radius away, one radius, if diameter is d, it will be d by 2, and it is up to this, again it will be the same uniformly distributed load, uniformly distributed stress, it will be 1 diameter away. If it is d, then here also it will be d. So your reinforcement pad should be design should be how much, should be how much. Now you see, this is the nodules. So this is the inner, this is the outer, this is the main cell, this is the reinforcement plate. So the area of this plate, outside plate, should be equal to the area of the nodules, and the area of the, and the thickness of this will be the cell thickness of the, equal to the cell thickness. So as it is used around the periphery of the nodule, so load of this tank will be equally distributed here with the cell, as well as this, so this will be taking 3, that is, I have told you the traces at the periphery of the nodule will be more, that's why the thickness is also more, so the stress developed will be carried by this main cell plus the reinforcement cell. So it will be distributed. Not all 3 sigma load will be there at the cell. It will be taken care by the reinforcement plate also, reinforcement ring also. So what should be the area of the ring, outside diameter of the A of your reinforcement pad? Now it will be equal to the area of this whole area of the nozzle. The area of this annular sheets will be equal to the area of the nozzle, and its thickness should be equal to the thickness of the cell, thickness to the cell. So this is the purpose of the reinforcement plate. And then this is the, if it is cell thickness, cell is material, is a very bigger, higher thickness cell is there, made the tank, then it should be prefabricated. You should be pre-bending and prefabricated, and that prefabricated sheets you have to brought outside and then do the welding as per the jacking method, So this is all about the tank manufacturing. I have told you everything, how to manufacture the tank in the traditional way, jacking way, the purpose of all the parts used for the tank, including your foundations, and your foundation bolt, foundation chair, everything. So if you go through these slides, your concept will be totally clear. If you still have any doubt, you can ask me by telephone, you can mail me, or you can make an arrangement with your management for a tele-discussion, so that the topic will be which is not clear to, will be clear to you. I can make you clear. I think if you are satisfied, you give me a tick mark and subscribe this channel. Share this channel to your friend. Not only you will be benefited, your graduate engineer trainee who are going to join fresh graduate engineer trainee. These all these things are not taught in your graduate engineer course. It is more detailed way to discuss. Sometime our engineer face lot of problems when they are directly placed at the sites without much more training. So if you go through this channel, my channel, your all concept will be clear. Till now we have discussed this tank, other thing, and tank lot of other post will come, particularly in tanks also. So you subscribe it, share it, so that you will get a good knowledge on this equipment that's called tank. Thank you very much.